all of the rules of transformation. So f of x is the original, and all of the transformations that apply and what you do to the actual x and y values on the graph. So the first two are our vertical shifts. If I add c to the function, it shifts the graph up by c units, all of the y values. So again, these would be your vertical shifts. And so again, the y, if you add, all the y values get added by the value, subtract, all the y values get subtracted. And they shift up and down. That's why they're vertical, up and down. If you add inside the function, so inside the function, every x value you add c to it, every every x value you subtract c from it. And then this is the one that's a little counterintuitive, right? This is the one where it's best way to think about it for me, this is the way I think about it, is you have to undo what's been done to x. So if I've added a constant to all the x values, to get back to the original function values, I have to put in minus that for the x. So I have to shift to the left that x. So so we're shifting to the left when I add inside. All of the x values, subtract that. Because again, I want to get back to x. So if I want to get back to x, I have to take that c value and subtract it. Same thing when you when you subtract, you have to add that c value to all the x values to get back to the original x. And so this is the horizontal shift. And horizontal means in the x direction, right? Vertical means in the y direction, up and down is the y direction. Horizontal is the x direction, left and right, the x direction. Alright, reflections. It reflects about the x-axis. When you multiply the entire function by a -1, all of the y values get replaced with negative y values. And so these are my reflections. If I multiply by a negative inside every single x value, inside my function gets multiplied by a -1, it reflects across the y-axis. All of the x values get replaced by -x. Alright, the stretches and compressions, or the stretching and the shrinking. Those are the hard ones, especially, I think, horizontally. Those are the tricky ones. Okay, so the vertical ones are the ones we do first. Those are the easy ones. So if I'm multiplying the entire function by a number, if that number is bigger than 1, that's a stretch, meaning I'm making all of the y values a times bigger. So every single y value gets multiplied by a. Right, if it's a vertical shrink by a factor of a, it means the a value is a fraction like 1/2, 1/3. We're multiplying by a half and a third. And again, we're multiplying by half is the same as dividing by half. So in this case, it's the same as taking the y values, divide by that a, which is, I think, the easier way to think about it. Technically, we're always multiplying. Right? But that's what you're doing. You're taking every single one of your y values, multiplying by a fraction like 1/2, 1/3, 1/5. And so they're all becoming smaller. Right? And so it's shrinking it in the y direction. It's shrinking it closer to the x-axis. That's what's happening there. It's pushing it or compressing it towards the x-axis. Alright, then the other shrinking is the horizontal, which again is always the harder case. Alright, so if we want to shrink the graph by a factor of 1 by a, again we call it 1 over a, that's when we multiply by a big number. Right, number bigger than 1. So if I multiply by 2 by 3, I'm really shrinking it by 1/3, 1/2. Because in order to get back to the original value, right, we'd multiply by that fraction, and that makes the value smaller by 1/2, 1/3. And so it compresses it in the x direction. Alright, so it compresses it towards the y-axis and makes it shrink. If my values are fractions like a third or a fourth, it stretches it, because when I divide by a fraction, it's the same as... So in this case, the last case here, when I'm stretching it, remember, these are values between 0 and 1, meaning they're fractions like 1/5. When I multiply by 1 over 1/5, it's the same as multiplying by 5. And so remember, this is the same as taking 5 times all my x values, because when I divide by 1/5, it's the exact same as multiplying by 5. Alright, and so that's the tricky case. But what it does is it makes it stretch. Is that pulling it away from the y-axis, stretching it out in the x direction. So it's stretching it in the x direction towards the infinity in the x direction and the negative infinity in the x direction. Alright, and like I said, the last two are the hard cases. At least for me, I have to sort of stop and think about what's happening. The easiest way for me to figure out what's happening in the horizontal cases, I have to undo whatever has been done to the x value to get back to my original function value. So if I multiplied by 2, I have to get rid of the multiply by 2 by dividing my x values by 2. If I multiply by a half, I have to undo that multiplying by a half by multiplying by 2, and so it gets stretched out by a factor of 2. Alright, and so like I said, those are the tricky ones that you just really need to practice. Now what's nice about you have a graphing calculator, you can always check your answers graphically. Alright, but there are all of the rules, and they're there in your notes there. These are all of the rules and what happens to the graph when they get affected by each of those rules. And now we're just going to practice kind of combining some cases. And we won't be doing too many, probably 2 or 3. And so that's the next set of videos, is looking at cases where we've got 2 or 3 of these in one application.